Проветримся.
So many people are now interested in the power of games.
And since 2014, we have been collaborating with the Finnish Game Jam Association here in Finland to organize game jams to develop games that have something to do with quantum physics.
Well, one thing that quantum computers are great with doing is producing random numbers.
The players have discovered strategies that have also physical meaning.
Something like 200-something games came out of that weekend.
I'm optimistic, but it may also be that it is much more difficult than what we think.
We're already there. We're in the quantum era.
Hi guys, my name is Ivan Yemshikov and this is the podcast that we usually do in Russian and it's called Проветримся. This is a Russian word that could be roughly translated into English as bleaching or hanging out. So the idea of the podcast is that several people discuss certain topic while walking around outside on the street and breathing the fresh air, because all of us spend too much time inside in front of our computers, right? So you have probably guessed that this particular episode is going to be in English. And no worries, if you don't speak English, there is a dubbed Russian version of the whole thing. The reason that it is in English is because in February I went to the capital of Finland, Helsinki, and took part in the event that was called Quantum Game Jam. These were amazing 48 hours. I loved every minute of it. There were people with very different backgrounds, starting from game design and finishing with quantum physics. There was quantum computer provided by IBM, and we all tried to build some game that would use quantum computer as part of the game mechanics. So we've got a very special episode for you today with professor of physics who is using games in her research in order to get new results, professional physicist who's building an actual quantum computer that you can put your hands on, because there is an actual open API that IBM provides to anybody out there who is interested to play around with the actual qubits. And finally, we have a game designer who also teaches game design in the Aalto University and organizes game jams for years. So put on your headphones, get out, have some fresh air, and let's hang out. Не будьте такими душными. Давайте лучше проветримся. Проветримся.
I'm a physics professor at the University of Turku and Aalto University, and I'm the chair of theoretical physics in Turku and the vice director of the Finnish Center for Quantum Technologies, which involves both Turku and Aalto University. So I'm a little bit in between Turku and Helsinki.
This is Sabrina Maniscalco. But for being a theoretical physicist, she's also one of two people who actually started the whole thing that's now called Quantum Game Jam.
Since 2014, we have been collaborating with the Finnish Game Jam Association here in Finland to organize game jams to develop games based or somehow that have something to do with quantum physics. And we do it for two reasons. One is research and the other one is education. So games that might somehow explain a little bit better or help to gain familiarity with quantum concepts, but also games for research.
So I've been game scholar since 2005.
This is Anna-Kaisa Kultima. She's the president of Finnish Game Jam and also an executive in residence at the Department of Media in Aalto University in Helsinki.
The game jam stuff has been kind of related to my research, but also been my hobby. And so 2012 or 13, Sabrina came to the University of Tampere, where I worked at the time, to explain that she wanted to do games on quantum physics. And like making games is super easy, but it's not as simple, and it doesn't work in the way that most of the people that don't have experience kind of think of. So the best way to understand how the kind of the world of game making works is to go to game jams or run game jams with professionals. So we ended up putting together a quantum game jam. So and ever since, like, we've been kind of learning more and more how to do these and like kind of what kind of games could come out of it, and we've changed the tech constraints, we've changed the thematic constraints, and so we've explored quite many things.
But it's one thing if you want to build a game prototype within 48 hours, and it's a new story if you use this game prototype in order to get some rigorous academic results. Now, one could expect that using games you can study some human behavior or problem solving, but using the games in order to get new results in, you guessed it, quantum physics, that's the whole new story to me. And that's exactly what Sabrina's group has been working on.
First of all, we are not the only ones doing this, and we are not the first ones. There's a group in Denmark by Jacob Scherson, Science at Home. I invite you to go and check on the internet, Science at Home. And they did already prove that it is possible to gamify some problems that involve time-dependent optimal control in quantum systems. And what happens is that there can be some situations where you're looking for an optimal solution of a complex quantum system, and the configuration landscape that would give you the optimal solution is very, very complicated. There are many valleys and mountains, and you don't know when you are reaching the optimal solution. So you want to explore the configuration landscape, so you want to try to somehow figure out what is the optimal solution. And you can do it with games. So you can develop a video game that, while played, helps you exploring the solution of the optimization problem of quantum physics. And this is what we are trying to do also here with something that we have developed and we call the quantum black box. And indeed what happens is that very often it is a combination between machine learning and gaming that is the optimal solution somehow. So what they proved in this Nature paper, Jacob Scherson and others, is that actually you could use the solutions of the gamers instead of random initializations as seeds for the machine learning. What is interesting, however, is that the players have discovered strategies that have also a physical meaning. So in a way, the thing that for me is fascinating is the fact that somehow when we try to think in terms of quantum physics, we as scientists, we are sort of biased by the fact that we know it very well, we are experts in quantum physics, but also there is this level of thinking that it is counterintuitive. So there are certain things we probably wouldn't explore because we still think in classical terms, and because we think obviously in math, because we think we know the math. But if you gamify it, then because it's a game, you can do anything you want. There are somehow no limitations on what you can do, and so the exploration of the landscape of solutions is much more free, and if the game is well designed, can lead towards what is helping somehow the players to reach the optimal solution. But of course this is a completely uncharted territories in a way. We have this one example in quantum physics, and of course we do have the famous Fold It, for example, that is one of the games showing.
Yeah, like when they were finding the structure of proteins, but this is more biotech thing, yes.
Yeah. But the idea is that, games might allow to do things that our classical mind wouldn't do, in a way, because we are limited in our thinking when it comes to quantum mechanics. Quantum mechanics is notoriously counterintuitive.
So basically, did I get you correctly? You're just saying that since it's a game, people tend to think out of the box more than if they are within this scientific paradigm.
And this happens both at brainstorming level, so at the level of gamification, and at the level of playing the game. So both when you develop the game, you have to sort of think differently to gamify a problem that is a quantum problem, but also at the level of playing the game, you don't have the limitations, because, for example, in the black box there are these interference, complicated interference between BCs and potentials and so on and so forth. But the games may not have anything resembling that. Maybe in some games have, but others may not. So basically you are free by your thinking, I have to move this first in this way and then in these other ways because this is how I would do it classically.
Did it already occur at some point that somebody was like, okay, we can do it in the game, and then they're like, oh, wait a minute, we could actually do it on paper as well?
Not on paper, but with optimization algorithms, yes. And also, in principle, you don't know if machine learning will help. Generally, what we try to do is benchmark with machine learning, and then try to combine the two. For example, the black box that we have here has two versions. The one without interactions, where we found actually that there is an algorithm for optimization that find Well, we don't know if it's a global optimum, but it finds a very good solution because it reaches one. So that is what we want to reach. So we do know what it should be. We did find an algorithm, but in the case with interactions, we don't know. We are developing the machine learning algorithm. It's not so tricky. The first reinforcement learning algorithms that we use, actually they do not learn. They unlearn at some point, so they don't work. But of course, you keep trying. We don't know. But again, this is like exploring another avenue, having the video game in a way. And ideally, you would like to combine both.
The software that Sabrina's research group is working on is called the Black Box, and it is a simulator of different quantum effects that the researchers would like to understand better. However, during the game jam, we could also put our hands on an actual quantum computer that was provided to us by IBM.
Well, it's a big thing to try and make software for quantum computers.
This is James Wooten. He's a physicist that currently works with IBM research.
We have algorithms that we've been developing for decades now, but also a lot of them have come from quite a mathematical and technical background. And it really seems like a nice thing to open it up to try and get people involved and inject ideas that we would never have thought of. And part of that means that you have to make the software and you have to make the hardware that people can use.
Okay, and now there are actually several systems by IBM that people can play around with, not only during the game jams, but all year round, right?
Yeah, there's no actual special access arranged for the game jam. It's just the completely normal public access that people are using here. So there's 2 devices that are online and you just have to sign up for a free account and then you can get playing with them. You can start off with a little GUI thing that we have, but you can also do it with coding.
Right, but you yourself actually designed several right? You designed some games based on quantum effects.
Yeah, so, well, I've only just joined IBM a few months ago, so most of this answer is me as a non-IBM.
Okay.
And it was getting to the point where I was a scientist working on quantum computing, and it seemed like it was such a sci-fi thing in the far future that it seemed like my research wasn't really affecting anyone in the real world. So because of that, I decided to make a citizen science game that people could interface with my research a bit. So I had a dream to be a game designer when I was young, but this was when it first really came into my adult life that I was doing things relating to games. And then that same year, like the revolution came. This is when IBM put devices online, and so my problem.
You could finally explain to people what you actually did for all the years before that, right?
Yeah. So then, because I already had the idea of trying to interface with the public and do that via games, it was natural that I wanted to first make some games using a quantum computer and use that to show people that it's not fancy factoring algorithms that you necessarily have to do with quantum computers. You can do more relatable stuff as well.
So I'm coming from the field of AI, and people are very excited in AI about quantum computing because of the fact that you have soft logic or fuzzy logic that's naturally implemented. Seems to be probably easier and naturally could be naturally implemented in quantum computation. What are other particular features of quantum computing that you think are like the thing? Why is it going to be bigger, and why you are personally interested in that?
The big thing that started off quantum computing was the realization that quantum systems themselves were something that are hard to simulate on a normal computer, but quantum systems simulate themselves just fine. So can we harness them to simulate other quantum systems that we want? And then it was a realization that this is just an example of another kind of abstract computing device that could be used for all kinds of other problems. And over the years we've found out that it's great for optimization, it's great for searching, it's a lot of interesting problems. You can find more efficient ways of doing it with a quantum computer.
Promo materials that IBM teases here in Helsinki, they say that it's also for commercial use, like the first quantum computer available for commercial and research use, but probably you need more than 5 qubits. So do you have any idea about the timeline?
Well, one thing that quantum computers are great with doing is producing random numbers. Yeah. So if you want a quantum random number generator, you need 1 qubit, and we have 1 qubit. So we're already there, we're in the quantum era. but that's maybe not the most exciting use. So what people are looking into now is trying to do something that can't be done on a normal computer. And it doesn't necessarily have to be something interesting or useful. It's just more for that. It's more for the scientific result of proving that this sort of thing can be done. So that will come hopefully in the next few years. And then after that, you have to then start looking at doing something that can't be done on a normal computer that is also useful. So we're already developing those sorts of applications now, and that means finding ways to fight the noise. We have this process of error correction, and I myself am an error correction researcher, so I know all about how you do that, but it requires very large overheads. You need to spend a lot of qubits to get one nice, well-behaved qubit. So in the short term, we'll be doing more sleeves rolled up, dirty, hacky ways of getting around the noise.
Speaking about hacky ways of people with rolled up sleeves, I'm sure since the start of this podcast you've been asking yourself, is it actually possible to develop a game within 48 hours? Like an actual game? This is Anna-Kaisa Kultime again.
It's a very short time in terms of game development. So usually our game jams are 48 hours. The full-fledged projects, they take months or years to make it happen. If someone from outside of game development would see their end results of the game jam games, oftentimes that is very near to the final product, because a lot of the things are set in the early phase, and then there's so much more work to make it very smooth and all the kind of the flow for the experience for the players, and create more levels, create more content. So at the end it can be so that we can create something in 48 hours that looks almost the same as the final product. And this has happened in other game jams. There's been, like, for instance, Surgeon Simulator 2012. The jam prototype looks almost exactly the same as the one that was kind of released 48 days after. We kind of get the initial ideas and the proof of concept here, and then it kind of determines, you can see from that whether it's like something valuable to be developed further. It doesn't always evolve to the next step. So development is not really easy concept in this sense, and we are now with the first game jam with actual quantum computers. So we might have development within that tool and also other tools that we provided, like the black box, so that it becomes kind of more stable and more easy for the developers to use. So that kind of development can happen, but not necessarily the concepts themselves.
Game development is actually a huge thing in Finland. With such world-known names as Rovio or Supercell, having only 5.5 million people, Finland is actually one of the titans of the game industry on a global scale. And this is true for the game jams as well.
We started in 2010 with Global Game Jam, and we've been with Global Game Jams ever since. And the kind of that's our biggest event in Finland in terms of physical game jam sites. This January we had 26 different places throughout the whole Finland to participate to the Global Game Jam. And then we had around 900 something of the participants altogether. Around 1,000 if we also count the organizers and everybody that helps running the whole thing. Something like 200 something games came out of that weekend. And if you compare, we've done some comparing like a few years back to the global game jam other countries as well. And if you compare to the capita, because Finland is very small, we are the biggest country. So relative numbers are super high.
What is the global outputs like for all the other game jams combined? It would be probably comparable with the Finnish game jam.
Yeah, the thing is that also in absolute numbers we were somewhere like in top 10. Which is like, there's like United States, UK, Australia, everything is there, the big countries as well. So
China as well, no?
China as well, yeah. So we do have a very active community of game makers in Finland. The number of the professionals working solely on companies that do games is around 2,700. So that's also compared to the capita quite high number.
But games are not only something that we use for fun. Games can also change social behavior of people, improve their well-being, and as we learned today, can be actually used for the research.
So many people are now interested in the power of games in a way that you don't have to make games themselves, but you take the elements from games and then turn them into, for instance, engagement projects. I don't know any other citizen science projects that would be with natural sciences. I think that those are like these are the projects that we hear from. They come from different kinds of countries. So, for instance, Aarhus in Denmark has done also citizen science project on the quantum physics. But there's a lot of talk, and it's a huge hype, for instance, for making different kinds of playable artifacts for people to engage with.
Aim of games generally is entertainment.
This is Sabrina Maniscalco again.
So you have the games that work have to, so to say, satisfy certain rules where you have some obstacles, which keeps it challenging, obviously, but it has to be not too difficult at the same time. So you need to make it, work as a game, just for fun. But these may not be necessarily the best solution when you need also to have a goal, which is a physical goal, that is optimizing a certain protocol. If I add enemies, actually this can lead me away from the optimization protocol. So it's by no means an easy task. I mean, I think that it will be a little bit like in machine learning, a trial and error type of thing. We just try and we have some fun with these. We organize game jams. We have now a small project, European projects, that is leading to commercialization of the quantum black box. Together with a company, we are thinking of commercializing this. I'm optimistic, but it may also be that it is much more difficult than what we think.
I believe that Sabrina has every reason to be optimistic about it. After all, quantum computing is only in its cradle, and such quantum game jams as this one that was organized by Anna Kaisa in Helsinki, backed up with the research results that Sabrina's group is working on, and combined with the hardware that companies like IBM try to develop, might actually at some point bring us to the world where quantum computer is available to everybody. But can we do something impressive with it now? Like right now? We sort of can.
The nice thing about quantum random numbers coming from a nice, well-understood, not noisy system is that they're not just something that's very hard to know what they would be. That you can prove that due to the nature of the universe, these are absolutely random. So you've got that certification in that case. It's not just, oh, these are pretty random and I don't know what they are. It's just pretty good randomness. You've got the whole universe attesting to the fact that they are the best random numbers you could ever have.
This is, it doesn't get better than that, I think. All right, thanks a lot. I think that would be enough.
Проветримся. Well, that is about it, folks. The next episode will be in 2 weeks and it will be in Russian, but we will have episodes in English from time to time, so stick around if you liked what you heard. Don't forget to subscribe and also send the link to our Telegram channel, which is t.me/PROGULKA. We've got a special music for you. This is Sluncher, Dennis Murphy's Polka. Не будьте такими душными. Давайте лучше проветримся. Проветримся.